Hello, welcome again. We are covering the subject compressible fluid flow for civil services means IFS and Gate Aerospace exam. So we are studying the topic Prandtl Meyer expansion wave, and in the first video we studied qualitative aspect of the expansion wave. So in expansion wave, the Mach number initially is supersonic and it increases across the expansion plan. Pressure decreases, temperature decreases, density decreases, and we also studied that the expansion plan consists of infinite number of waves or lines. So this is your forward Mach line, and this is your rearward Mach line, and this is your uh, forward Mach angle, and this is your rearward Mach angle. And we also studied that the expansion through the expansion plan is isentropic, and pressure P2, T2, temperature T2 are less than pressure P1 and T1. Okay. So now we'll drive, and theta 2 is force deflection here. Now we'll drive the relationship between these Mach numbers and this deflection angle. So this is called quantitative analysis. Okay. Starting with initial Mach number M1, pressure P1, temperature T1, and suppose deflection angle is theta 2, and then we have to calculate M2, P2 and T2. Okay, so to drive this we'll consider a small deflection. So this is initial wave having velocity v. Okay, in vector diagram it is v, and this in making an angle mu, this here it is mu1, so it is mu with Mach wave. Okay. So now suppose this is deflected by a small angle, this v is deflected by a small angle v plus dv. Okay, and this angle is your d theta, small angle is d theta, and in this deflection the velocity increases and velocity becomes v plus dv. Okay, so this is your v, this is v plus dv, this is d theta, and this is your v. So if we draw this v plus dv and this and extend it and draw it perpendicular, then this will coincide with back wave. So this angle is your 90 or pi by 2. So this angle will be your pi by 2 minus mu. As this hole is 180, so it is pi by 2 plus mu. So this will be your, this is d theta, this is pi by 2 plus mu, and this will be your pi by 2 minus mu minus mu. Okay. So now this is your velocity. This is this v plus dv, this is d, and this is the third side. So this is your velocity diagram. So we can apply sine rule in this. So v by sine of this and will be equal to v plus dv by sine of this, or we can say v plus dv by v is equal to sine of pi by 2 plus mu divided by sine of pi by 2 minus mu d theta. Suppose this is equation number 1. So now we can modify this sine pi by 2 plus mu as cos mu, okay, and this as cos mu plus d theta, and we can further apply the formula of cos a plus b, cos mu cos d theta minus sin mu sin d theta. This is equation number 3, and putting here. So this will become equation number 4. So now in this we can also take d theta small and cos d theta as 1, and sin d theta as d theta. So then the equation will become become 1 plus dv by v is equal to cos mu divided by cos mu minus d theta sin mu, or further it can be modified as 1 by 1 minus d theta tan mu. So now this expression can be written as, or 1 by 1 minus x can be written as 1 plus x plus x cube. Okay, or taking only first two terms, so it can be written as 1 plus d theta tan mu, or d theta is equal to dv by v by tan mu. Now we can put the value of mu, that is sine inverse 1 by n. So as it is sin inverse 1 by n, so tangent mu will be here 1 by root n square minus 1. Okay, so now we can put the value of tangent mu here, and 1 will cancel out, so it will be d theta equal to root n square minus 1 dv by d. This is equation number 8. So now we will solve this equation number 8, which is called governing equation for Prandtl Meyer law. Okay. And as it is this is small, so it is a approximate equation for finite value of d theta, but for small value of d theta it is valid, and it is derived based on the geometry as we have derived. So it is derived strictly on the basis of geometry, where only real physics is restricted with the definition of a MECH wave. Hence it is a general relation which holds the perfect gas, chemically reactive gases and real gases. So it is valid for all this. Now third main aspect is it treats an infinite small expansion angle d theta to analyze the entire Prandtl Meyer expansion integral. So d theta is very very small angle. So these are the basic assumptions of this equation. Now we'll find the result from this equation. So if we integrate it within the limit, then the limit of d theta is theta 1 is 0, because the initial surface is in the line of your line of flow, and final reflection is theta 2, so final limit is here. Initial Mach number is m1 and final Mach number is m2. So now this Mach number can also be modified, taking b is equal to ma, so ln b will be equal to ln m plus ln a. Differentiating it to be dv by v is equal to dm by m plus dA by a. So now further from the energy equation, we have T naught by T is equal to 1 plus gamma minus 1 by 2 m square, or we can say A naught by A naught by A whole square is this same value, or we can have A is equal to A naught, solving this bracket 1 plus gamma minus 1 by 2 m square, bracket close, base for minus 1 by 2. If we take ln, this will be ln A naught will be equal to ln A naught minus 1 by 2 ln 1 plus gamma minus 1 by 2 m square, bracket close. So if we differentiate 12, then it will be dA by A, and so this is dA by A, this will be 0 because it is constant. This will be a minus gamma minus 1 by 2 into 2m into 1 by 2, 2 to be considered, into divided by 1 plus gamma minus 1 by 2 m square into dm. So this is the representation you can do it. Okay, now we can put this dA by A in this equation number 11, and find out dV by V. Okay, you can solve it by yourself. This is dm by m and this is your dA by A. So it will be dV by V, dm by m, bracket 1 plus 1 by 1 plus gamma minus 1 by 2 m square. So this is equation number 14. Now this equation number 14 can be put here and integration can be performed. Okay. So it will be theta 2 equal to m2, limit m2 to m1, and putting the value of dV by v, it will become root m square minus 1 divided by 1 plus gamma minus 1 to m square dm by m. This is equation number 15. Okay, and it is called Prandtl Meyer Meyer equation. Okay, and we'll solve it in the next.